This isn't just math. It's a gatekeeper.
Harvard Qualifying Exam, 2022. Most students freeze when they see this.
It looks terrifying, but we're going to completely dismantle it. At first glance, it looks so innocent, almost cute, right? But look closer. Why does that denominator look so chunky?
That little power of 2, that is a total monster in disguise.
It's a trap, a beautiful, terrifying trap designed to lure you into a fight. One of those messy algebraic fights that leave you totally exhausted. But we aren't going to fight it head-on. We're going to be lazy. I'll show you how one tiny, clever little variable makes this whole wall of math just snap, melt away. We're going to solve a much prettier version instead. We'll swap the 3 for a variable a and ditch the square for now.
Meet J of a. This isn't just a simplification, it's a gift.
This is our secret weapon, and the payoff? Pure magic. Hold on, why did we invite this total stranger, J of A, into the house? Is she just making life harder? A total messy distraction? Actually, she is our Trojan horse, a legendary setup for a sneak attack. And hidden deep inside her wooden belly is our secret weapon. The ultimate banger of a technique, differentiation, under the integral sign. Time for a pincer attack. Let's differentiate both sides by a. Now, hold your breath. This is where the magic happens. The derivative just slides right past the integral sign. Whoosh! Boom! The power rule strikes! Look at that beautiful transformation. And that negative sign, a satisfying plot twist to keep us on our toes. Wait, do you see what I see? This is absolutely miraculous! Our derivative is the perfect twin of the monster we're hunting. We find J of A, take the derivative, and just plug in 3. And just like that, it's game over. Pure, unadulterated mathematical magic. Time to face our first boss, the legendary integral J of A. Why does it look so stubborn? It is that cosine lurking in the basement. To beat it, we are summoning a secret weapon, a total game changer. Say hello to the Weierstrass substitution. I call it the shadow projection. It maps our circular world onto an infinite line. As theta sweeps the ring, its shadow t races towards positive infinity. At the pole, the shadow jumps across the universe, returning from negative infinity. These are our translation keys. They turn geometry into pure, raw algebra. Now for the surgery. Every piece of theta gets swapped for its shadow. Watch closely. It looks messy, but wait for the twist. Those denominators are about to vanish. We group the terms, and look, a beautiful structure emerges from the chaos. Taking a detour, how do we solve this? We aim for the golden rule. Step 1, the golden rule has a 1. We have an A. Let's force it out. Step 2, we identify the mask. We need u squared to match that term. Step 3, swap x for u, and don't forget to pay the tax on dx. Gather the constants, factor them out, and simplify. We found the golden rule. it becomes arctan. Then we put the mask back on. We match the patterns. A is A plus 1, B is A minus 1. We plug them in and apply the limits from negative to positive infinity. The arctan at infinity gives us pi over 2. At negative infinity, negative pi over 2. The difference between those arctans gives us a perfect golden pi. Look at that! Clean, powerful, and ready for the final act. Look at this beauty! We've survived the algebraic wilderness and brought back the prize, a legendary trophy. Curious, but this trophy is actually a sleeping engine. Let's wake it up. We're going to nudge this function until it surrenders its deepest secret. Behold, J prime, the key to our original integral. Now watch the mechanics. The power rule is basically gravity here. It pulls that negative 1/2 crashing down to the front. Boom! Absolute impact. But don't look away. The chain rule is reaching inside like a secret agent. And kicking out a 2A as a parting gift. Absolute banger. Oh, I love this plot twist. This is where the clutter just vanishes. The 2's, they just evaporate, leaving us with something remarkably clean. And there she is, the final, legendary form of J prime. Look at how perfectly it sits on the page. Pure mathematical elegance. It's miraculous how all that chaos just settles into this beauty. Look at this legendary beast. This is the moment we've been fighting for. The aha moment we've been hunting. The legendary payoff is finally here. We've built this glorious engine. Now, let's hear it purr. Behold, the skeleton key. This isn't just some dry, dusty formula. It's the secret weapon that's going to crack this nightmare wide open. But remember our target? Our original monster had a 3 sitting right there. So we're going to swap every A for a 3. Lock it in. Dropping it into the machine, watch those gears spin. Wait for it. The double negative. Look at it. They don't just cancel. They evaporate. Pure mathematical magic. Seeing that chaos turn into perfect order, that's pure dopamine. 8 to the power of 3 halves. Sounds like a final boss, right? But it's just 16 root 2. Elegant, clean, and exactly what we earned. And now, boom, the grand reveal. 3 pi root 2 over 16. Isn't that just miraculous? This isn't just an answer. It's a total masterpiece of logic. We took a terrifying monster and dismantled it piece by piece. Stay curious, my friends. See you for the next banger. Class dismissed.